Okay, I want to take a few moments to go over the lesson outline for this chapter. We've talked about waves. We've talked about the properties of waves. This is the way we're talking about the ways waves behave in terms of when they interact with matter or when they interact with other waves. Okay, so the first one we're going to look at is what do waves do when they interact with matter or actual material? Well, one way they can be impacted is they can be absorbed. Absorption is the transfer of energy by a wave to the medium to which it travels. So whereas you might hear sound, if you're in another room, you might hear sound from the other room. If it's talking, it's not as loud as it was in the other room because as it goes through the wall does absorb, take some of that energy. Remember, energy can't be lost, but it can be transferred. In this case, it can be transferred to the wall. One factor that affects the amount of energy that's absorbed by the medium is the medium. So if looking at light, it's also the material. So for light, we'll talk about this when we talk about light itself. When we talk about materials, when light goes through material, it can be transparent, where all the light gets through. It can be translucent, where most of the light gets through, or opaque, where none of the light gets through. And the same wave of light can impact differently through different mediums. So this is a piece of glass, this is a piece of wax paper, this is a piece of aluminum foil. We can see how the light is going to travel differently through those mediums. Now, all materials absorb electromagnetic waves. Remember, electromagnetic waves can travel through matter. They don't like to. They like to go through a vacuum, but they can. But all materials will absorb some of it. If the wave passes through material, that's transmission. For example, light going through a window is transmission, is the passage of light through an object. So light going through a window would be transmission. Another thing that waves can do is when they strike an object is they can reflect. Reflection is the bouncing of a wave off of a surface. If we were talking about color and what they reflect, what they absorb, briefly we talked about that yesterday. Objects reflect all the visible light spectrum are going to appear white. White contains pretty much all light frequencies in it. We just don't break it apart normally. So if you have a polar bear eating ice cream on a snowstorm, that's a lot of white. Now, if it doesn't reflect any visible light, they would appear black. They absorb all colors. That's why wearing a black sweater on a hot summer day is very warm, because black material absorbs all of the colors of light spectrum coming from the sun. Now, again, waves can reflect off of objects. If they do reflect off of objects, there is a law of reflection. Remember, all types of waves can be reflected back when they hit a surface. A sound wave, a water wave, a light wave, all these things can be bounced back. Now, when they bounce, there is a law of reflection. Basically means that the angle of incidence, the angle that light comes in at, is going to be reflected exactly on the angle of reflection. So the angle of incidence, where it came in, is the same as the angle of reflection. You probably haven't thought about this, but if you're shining using your phone to shine light off of the sun on someone's face, you're using this reflected angle, not even thinking about it. In this situation, if I have what's called a plane mirror is a flat mirror. The line that is perpendicular to that flat mirror is called the normal. It's basically how we get our measurements. So the incident ray is the difference between the ray and the normal, and then the reflected ray would be between the normal and the reflected ray. But that individual, this imaginary line is called the normal. It's perpendicular at 90 degrees to a flat surface. So again, the law of reflection is the angle of incidence is equal to the angle between the normal and an incoming wave. So the angle coming in, if this is 45 degrees coming in, it bounces off at 45 degrees. If it's 30 degrees, it bounces off at 30 degrees. Whatever the angle is coming in, it'll be the angle going out. So again, the angle of reflection is equal to the angle between the normal and the outgoing wave. So that's the reflected ray, and those two are always equal. So the law of reflection, once again, is the angle of incidence, which means the light coming in is equal to the angle of reflection, the light bouncing off. Okay, so they can be absorbed, they can be reflected, they can also be refracted. So absorbed was transferred energy into, reflected was bouncing off of, refracted is going to be bending through. Refraction occurs when a wave changes direction because its speed changes. We talked about briefly that waves change speed through different materials. So as this laser beam hits this glass plate, it changes direction. As it leaves the glass plate and goes into the air again, it changes direction again. This changing of angle is called its refraction. Refraction, bending through. The greater the change in speed is, the more the wave changes direction. So if we have water waves, this is actually the same image, but because the light's being bent this way, it looks like it's reversed. We can see that this glass, here's the straw, but here's the straw. The reason they look different is because the light is bending differently in the water of the glass than it is through the air of the glass. That difference of bending is its refraction. And then the last thing they can do is a process called diffraction. The change of direction of a wave when it travels by the edge of an opening or travels through an opening is called diffraction. So there's a couple different ways it can happen with light. What's going to happen is, as the light goes through this small opening, it's going to expand. This leads us up to periods of interference. We'll deal with this later in the year, or later in the week, actually. But it's also the reason that sound can bend around a door. You might be able to hear somebody in the hallway. That's because their sound waves have the ability to bend around the door or diffract around the door, depending on how you look at it. So sound waves spread out as they travel through a doorway because their wavelengths are roughly the same width as the doorway. Because sound is such a longer wave than light, and even radio is even longer, you'd be able to hear this as you come around the corner. The radio's here playing, you'd be able to hear it. If you ever heard something around a corner, you know the sound does bend around a doorway or around a corner. That bending around the object is its diffraction. Now, again, light can diffract as well, but it doesn't diffract as easily. So if this guy's wearing a headlights and singing or whistling, this guy would hear the noise because the sound waves would diffract, but the light would not, because the light would not spread out as it goes through the doorway. So light's not going to bend or diffract as much as sound because light has a much more higher energy, so it's not going to bend as much. Now, when waves interact with other waves, then we have what's a process called interference. So when waves interact with other waves, we call that interference. Interference occurs when waves overlap to form a brand new wave. So this is a form of constructive interference. So if he bounces at the right time, he applies his energy to this guy, so he gets a lot more height. That's a constructive interference example. And constructive interference occurs when crest overlap with the crest or trough overlap with trough. And basically, because the waves are in sync, because he's going at the right time, each time he's building bigger waves. So when the two waves match up and crest to crest or trough to trough, those two waves combine to form a bigger wave. We can see that the amplitude of this wave is bigger than the amplitude of the other waves. And why is that? Because they are building and becoming one bigger wave. They are constructing a larger wave. Constructive interference builds a larger wave. The other version is destructive interference. If I line up crests and troughs, if I line up, they're going to cancel each other out. So if you can see these two waves coming in, what happens is because the crest and trough line up, they basically cancel each other out. That is destructive interference because they're basically destroying the wave. Okay, so we see two waves, but because they're off cycle, they form one. This actually would be a flat line if it was exact. Noise canceling headphones work in this manner. And if we have a wave that's kind of sitting for a long time, when those two waves overlap again and again and again, we can get a standing wave. As the wave kind of sets, so we see the two waves, the red and the blue. What we get is that black standing wave as a result of those two waves. And we can see when the crests line up, we get those big parts. When they don't, we get the little parts. Hopefully that is helpful to you. If not, you can ask questions during study hall, or I will see you tomorrow. Have a good rest.